Hi everyone, I am Dr. Kiran Raavi, working as an assistant professor in the Department of Electronics and Communication Engineering, MLR Institute of Technology, Hyderabad, India. Today we are going to learn about SCR. SCR stands for Silicon Control Rectifier. So today's presentation, overview of today's presentation are start with introduction to the SCR and what is the construction of Silicon Control Rectifier, what is the working of Silicon Control Rectifier, and we will discuss its characteristics, and then we will discuss the applications of SCR, conclude with the summary. So coming to the introduction to the SCR, Silicon Control Rectifier converts high power AC signals into constant DC output signals. So rectifier, the name itself represents a rectifier which converts AC signal into DC signal. So but normal rectifier, diode rectifiers are there. So normal diode rectifiers are used to for convert low AC signals into the constant DC signals. So whereas SCRs are very effectively used to convert high power AC signals into the normal DC, constant DC signals. Now, and the SCR is also called as thyristor, is one of the semiconductor device and is used in high power switching applications. So these SCRs mainly used in high power switching applications. So its peculiar characteristics are there. So we will discuss in the following slides. The working of this device should be possible in switching mode only and act as a switch. So working of this device should be possible in switching mode only and acts as a switch. When the SCR triggered by its gate terminal into the transmission, then it will supply current constantly. So this is advantage of SCR. So SCR triggered by its gate terminal into transmission, then it will supply the constant current constantly. So ultimately we require constant current from high output, high AC signals. While planning an SCR, so when planning an SCR or thyristor circuit, exceptional focus ought to be expected for enacting the circuit. So these are used in devices like dimmers, conduct current in only one direction only. So these are the basics of introduction to the SCR. Construction of SCR. So you can observe here, so this is the construction of SCR and symbol for this is normal PN junction diode, and to this there is another terminal. It is a 3-terminal 4-layer device. 4 layers, 3 junctions, 3-terminal current control device. So this is the symbol. See here, 3 symbols. So anode, cathode, and this is gate terminal, 3 terminals. So if you observe here, so what are the 4 layers? So it either PNPN or NPNP. So 2 different types are there, and first 2, this is one PN junction and this is another PN junction and this is another PN junction. So total 3 junctions are there. So hence we can say the name itself 4-layer 3-junction 3-terminal current control device, because the output current, the current flowing through the SCR between anode and cathode can be controlled by the gate current. The anode is the essential terminal through which the ongoing streams or enters the gadget. So the anode is the essential components. So this is anode of the SCR. So through which the current is flowing into the SCR. The cathode is the terminal through which the current leaves to the device. And anode, cathode. Now in the middle of the progression of current among the terminals, there should be a terminal that is called gate control, given control. So that can give the control. See here in the middle we have so to this we have connected the gate terminal. So in the middle of the progression of current among the terminals, there should be a terminal that can give control. So what is that control terminal? Gate. The intersection J1 in the middle of between the main P and N-type semiconductor. So junction 1 means what? The first PN junction. And then J2 means this one, NP. J3 means again PN. The second intersection J2 will middle of between N-type and subsequent P-type layers. Okay. So this is the basic construction of SCR, silicon controlled rectifier. So now let us see how it works. Operation of SCR. So reverse bias junction. J2 is known as junction capacitance as it acts as a capacitor in this mode. So J2, junction J2 acts as a capacitor because this side, for example, acts as a capacitor depletion region here. And no current flows through the device, but due to drift of mobile charge carriers, a small amount leakage current flows through the circuits. This state is known as forward blocking mode. So the operation of SCR will be in three modes. One is forward blocking mode, second one is forward conduction mode, and third one is reverse blocking mode. So three modes are there. So in first mode, what happens? We are not giving any input supply. So during no current flows through the device, but due to drift of mobile charge carriers, a small amount of leakage current flows through the circuit, the SCR initially. Okay. So that state is called forward blocking state or off state, as it blocks the forward bias voltage. So, and then the cathode is more positive compared to the P layer near the anode junctions. So G1, J3 are reverse bias and middle junction J2 gets forward bias. So no use. So J1 junction J1 and J3 are forward bias, even apply some voltage between anode and cathode. So gate is reverse bias. So therefore junction J2 gets forward bias if you apply any positive voltage because it is connected to P type. Okay. So when gate is positive, given by some positive supply and it is connected to P type means it gets forward bias. But whereas these two are reverse bias, even J1, J3 are reverse bias, there is no current flow through the SCR. So as the junction J1 and J3 reverse bias condition, they do not allow any amount of current to flow through the device. This state is known as reverse blocking mode or off state. The width of the depletion layer at the junction J2 may be reduced. At some particular voltage, J2 disappears. This is due to the breakdown of the junction by large voltage gradient, also called as avalanche breakdown. So avalanche breakdown takes place in the SCR when some particular voltage is applied on either side, that is gate voltage and anode to cathode. So device starts conducting and hence it is said to be conduction state or on state. So when both sides, if you apply positive supply, so then you can expect some current through the linear current through the SCR. So let us see, so one by one, the different operating modes of SCR. So I will explain here the different operating modes. So before going in detail about characteristics of SCR, so let me explain different operating modes. So we have different operating modes. First one is forward blocking mode. So what happens forward blocking mode? So we are not giving any supply. So let us say this is your P, N, P, N and this is gate and this is anode and this is cathode. So I am giving only this voltage. Across anode cathode I am giving, so we are not giving any gate voltage. So let us say gate voltage is 0. So we are giving 0, VG, gate voltage is 0. And this is reverse. So but here positive and negative. So P is connected to positive means forward bias. and minus is connected to negative because cathode is negative terminal and this is anode is positive terminal. So negative is connected to cathode. So this is again forward bias. So junction J1 forward bias, junction J2 forward bias, but junction J1 J2 forward bias in this. J1 J2 gets forward bias. Excuse me. J1 J3 gets forward bias. What about J2? J2 is reverse bias because we are not giving any voltage. So when this J2 is reverse bias means the depletion width increases at the center junction J2. The depletion width increases at this point, junction J2. So let me write clearly. PN. This is 0 gate and this is plus and minus. See here. So junction J1, J2, J3. So J2 is reverse bias. So even though the anode and cathode junction J1 and J3 are forward bias, because of the reverse bias condition of across J2, there is a increase in the depletion width at the junction J2. So when the increase in the junction J2, depletion width increases means, so there is no chance of current flow through the between anode and cathode. So that blocks the current flowing through the SCR. So but there is a minute current flowing through the SCR, that is due to some minority charge carriers. So initially there is a minute current flow like this. This is the minute current. Current is almost of the order of microamperes. This is for first case. This is called, what is the condition? This mode is called forward blocking mode because junction J1, J2 are, even though junction J2 are forward bias, junction J3 is reverse bias. So even though two junctions are forward bias, because junction J2 is reverse bias, the depletion width increases. So depletion width increases means there is no chance of movement of charge carriers from anode to cathode. So this is blocks the current flowing to the SCR. So this is called forward blocking mode. Forward blocking mode. Forward blocking mode. Second case is forward conduction mode. So in forward conduction mode, so let me write this. PN. Forward conduction. In forward conduction mode, so anode and this is cathode. So anode is connected directly and cathode. So gate is also connected to some positive voltage. So when gate is connected to some positive voltage, so obviously what happens? So junction J1, J2 and J3. So sometimes let us say this is, we are not giving any voltage here. So gate also not giving. In such case also, so here plus minus. So we are giving some positive voltage to the gate. So gate current controls the current flowing through the anode and cathode. So because all the junctions are gets forward bias, so there is a chance of movement of anode to cathode. So current flowing through the SCR due to, this is the called forward conduction mode. So in this forward conduction mode, initially there is a voltage drop. So due to that voltage drop, voltage will be reduced to here. So voltage is come back to here. So and after that, in the third case, so the current increases rapidly. So that is the region 3. This is called negative resistance region, or sorry, forward conduction mode, right? And now second case, the third case, if you see the third case, so I am writing here third case is reverse blocking mode. What is reverse blocking mode? So this is PN, junction 1, junction 2, junction 3. So anode is reverse bias, anode cathode. So there is a reverse bias between So anode is connected to negative and cathode is connected to positive. Obviously reverse bias, reverse bias. Even though you are giving any voltage here, gate voltage. So all junction J1 and J3 are reverse bias. So there is no current flow through the diode, the silicon controlled rectifier. And we can say this is a reverse blocking mode that blocks the current flow through the diode. So, but there is a avalanche breakdown takes place if you increase this negative voltage, reverse bias voltage between anode and cathode. So that will gives you the avalanche breakdown takes place, and this is the breakdown voltage. After avalanche breakdown, so you will have drastic increase in the current. So this represents your VI characteristics of silicon controlled rectifier. So it's operated in 3 different regions. Okay. Now applications of SCR. Voltage regulation. So these are used in voltage controls and stabilizers, protection devices. So SCRs can act as a security gadgets in flood, silencers, and then uninterrupted power supplies. So UPS. So power control, dimmer switches for lighting, engine, speed control, and stage point control. For warming components and rectification. So AC to DC and thyristor control panels used in thyristor control boards for the productive control of different modern cycles and apparatus. Okay, so these are the few important applications of SCR. So coming to the, so let us conclude for today's session. So we have discussed introduction to the SCR silicon control rectifier, its basic construction, and we have discussed working of SCR, followed by we have different operating modes of SCR: forward blocking mode, forward conduction mode, and reverse blocking mode. 3 operating modes of SCR we have discussed, and followed by we have discussed characteristics of SCR and different applications of SCR. Okay, so that's all for today's session, and next topic will be UJT, the last topic in this unit. Thank you.